Uh, some of the stuff in here can be a little bit challenging, but if you show your work and stay organized, it's just going to be a lot easier. But I do think it's doable. I think you guys will get this. I want to start out with just these conversion ratios. I don't expect you to memorize these. As you go through life, especially if you go on in math, science, knowing these will be helpful. I'll plan to give you the ones that you need to know, other than the ones that I think you already know from memory, and then you can ask about those and I'll hook you up. But I wouldn't stress about knowing them. But how many millimeters in a centimeter? 10. So you're thinking of a meter stick. A centimeter is the one there's 100 of them on a meter stick. It's about as wide as your pinky finger. You have 10 of the little lines in every 1 centimeter. How many centimeters are in a meter stick? 100. So 100 centimeters are in one of those meter sticks, about the same as a yardstick. And how many meters are in a kilometer? 1,000. Nice. You guys just holler them out. I love the hands, but you can just holler it out. Okay, on metric? In the U.S., because we're like one of maybe 2 countries, or just one of one, that uses our measurements. So how many inches in a foot? 12. Does that make sense? How many feet in a yard? 3. How many feet in a mile? 5,280. 5,280. So nice. So where the metric system, once you get to know the metric system, it's really cool. But we're sticking with what we have because it's cheaper and we already did roads and stuff that way. So okay, then converting units. So the key is this. I could take and multiply any number by 1 and not change its value, yes? So I could multiply everything by 1. Do you agree that 5 over 5 is 1? I wouldn't write that, but 5 over 5 is 1, yes? Yeah. So if I multiply by a fraction where the top amount is the same as the bottom amount, I'm multiplying by 1 and I'm not changing the bigness of the number at all. Good? Yeah. If I were to multiply by 12 inches over 1 foot, am I still multiplying by 1? Yes. Because 12 inches and 1 foot, they're the exact same, right? Mm-hmm. What if I were to flip that and have 1 foot over 12 inches? Yeah. Still the same. So what we could do is we could take these, let me quickly erase those, but we could take any of these things up above, like this, and make that a fraction, 1,000 meters over 1 kilometer. Or we could flip it, say 1 kilometer over 1,000 meters, and when we multiply by that, either of those fractions, we don't change the value of our number at all, because we're multiplying by 1. We're multiplying by a distance divided by a distance. Good? Or you could multiply by 60 seconds over 1 minute, and we're multiplying by 1. We're not changing anything, yes? Not changing the value of the fraction. All right, let's hit the notes. So multiply by a ratio that leaves you with the correct units. And some people will actually enjoy these. Some people hate these, never mind, bad example. Okay, convert 3.1 miles to feet. So I'm going to start just by writing 3.1 miles. I'm going to do MI for miles. Units will be helpful here. Because we're going to be multiplying by a fraction, I want to say I can put this over the number 1. So 3.1 miles is the same as 3.1 over 1. Now, we want to change this to feet. So we're going to go and we're talking about, okay, I need to do miles to feet. Totally do know how many feet are in a mile. This right here, yes? So now here's my question. I wouldn't write it yet. I could multiply this by 5,280 feet over 1 mile. Or I could multiply it by, I could flip that and say 1 mile over 5,280 feet. If I multiply it this way, do any of my units cancel out? No, because I'd have miles times miles here in the numerator, which would give me miles squared over feet. That makes it worse, right? But instead, if I would flip that red fraction, if I put my 1 mile down below, do you agree when we're multiplying fractions, we can cancel out something in the numerator with something in the denominator? And miles are now gone. We could say, well, in the numerator, I have 5,280 feet. Do you agree the only units left in the problem now are feet, which is exactly what we want? So when I multiply these two fractions, I'm going to have 3.1 times 5,280, which gives me 16,368. And the units that are left in the numerator are feet. Agree? Feet are the only thing that's left. In the denominator, I have 1 times 1, which is 1. And are there any units in the denominator? No. So my final answer is there's 16,368 feet in 1 mile. Yes? Because we multiplied it by 1, we have the same distance, the same length. All right, so if we jump down here to number 2, I want to convert this many meters to kilometers. So 5,623.6 m, lowercase m for meters. I really encourage you to start by putting that over 1. So we have a fraction. Now, we go up above, we have this thing here. This thing here. 1,000 meters equals 1 kilometer. If we want meters to drop out, do we put meters on the top of our next fraction? So we could put a fraction here. Does meters go up here or meters go down there to cancel? Down below. So we want to put meters down below. And how many meters is it?
1,000.
Perfect. So we have 1,000 meters. In the numerator, we'd write 1 km or 1 kilometer. And now when we do that, if we just look at the units, meters drop out. And in our final answer, we're going to be left with a kilometers over no units. So a kilometers over 1, essentially. Yes? So we just have the right units in the denominator. Okay. So now when I actually do the multiplication, I have 5,623.6 times 1. A lot of people skip this step. But I'm going to write, it gives me 5,623.6. In the denominator, I have 1 times 1,000, which is 1,000. So then I could do my 5,623.6 divided by 1,000, and I get 5.6236. And the units have to be kilometers. So that's all that's left. How are we doing? Good? That's really the point. Example 3, I get a little more dicey because we can't get there in one step. So we're going to have to do more than one step. So wondering, if each time you run, if your stride is about 1 yard, we'll say, how many yards are there in a marathon? How many steps is it going to be for a marathon? So it's 26.2 miles in a marathon over 1. So if we look up above, I don't have a nice, we'll come back down to the bottom if you're there, but I don't have a nice change miles into yards. I can change miles into feet. That doesn't get us where we need to go, but once we're there, we could change feet into yards. So I'm going to go back up here then and say, all right, I'm going to do my 1 mile is 5,280 feet. Where do I put my mile? Numerator? Denominator? Denominator. So I have 1 mile in the denominator. I always start with that. The unit I want to cancel out, I figure out where I put it. Then up above, I can change that to feet by putting 5,280 feet. So far, I'm rid of miles, right? I just converted it to feet. Now we could use that other ratio up above. Do we do 3 feet is 1 yard? 3 feet over 1 yard, or do we do 1 yard over 3 feet? Uh-oh. Where does feet go? Numerator or denominator? Denominator, because we want feet to cancel out. We don't want feet in the problem. We want yards, so we'd have yards. So is it 3 over 1 or 1 over 3? 1 over 3. Because there's 3 feet in 1 yard. Now if I multiply these out, I get 26.2 times 5,280. So I'm going to have 138,000. Perfect, 336. And the only unit that's left in the numerator is yards. In the denominator, I do 1 times 1 times 3, so I get a 3. Any units down below? Nope. So then last but not least, I could do 138,336 divided by 3, and I get... Is it 46,000?
Yeah, 46,112.
Perfect. And then that'd be that many yards. Maybe YDS or YD, something like that. I would encourage you to do them that way. You're always going to get some people that they try to do more in their head. I don't know if I'll put a show your work for credit. If I do say show your work for credit, this is what I'm looking for, kind of the natural steps. This is kind of the building blocks. Soon we'll start doing things where instead of just being like miles to yards, it'll be how many miles per hour. Convert that to meters per second. So you need to go from miles to meters and from hours to seconds. So it's possible that you have a lot going on. Yep. Then my next thing, proper units. This here you'll probably get like a couple questions on the quiz or test that say what would be a good way to measure this, and if you have something that's reasonable, I'll go with it. So okay. Measures for weight. The key thing here that's going to mess people up is weight and mass. We're kind of sloppy in the States with those. We kind of use those a little bit interchangeably. So on the quiz, on the test, these are going to be the ones that people are most likely to get wrong. So if I were you, I'd put a star by that and say like study or something like that, because those are the common mistake ones. Weight. If you have a small amount of weight, often they measure that in ounces. So I'm going to write ounces, and I'm going to do a little OZ for that. So small amounts of weight, often in ounces. Medium, things that weigh more than an ounce, you might measure that in pounds. And usually for pounds, they'll do, I'm going to put in parentheses, a LB, lowercase l, lowercase b. And if we wanted to convert that, so the conversion ratio, how many ounces are in a pound? Nice. So you could say 16 ounces equals 1 lb. 16 ounces is 1 pound. If you have a big weight, something's really heavy, we're going to measure it in tons. Nice. So tons, or ton. Abbreviation, lowercase t they use for time. So it'll be a capital T. How many pounds in a ton?
2,000.
Nice. So 2,000 lb, or lbs if you wanted to, equals 1 capital T. We doing all right for weight? Nice. Do the same thing for time. Short amounts of time we measure in seconds. So seconds. I'm just going to do a singular second. And then parentheses, lowercase letter s. Medium amount of times we might measure in minutes. And usually they'll do a lowercase min for that. And you know it, but you could write it if you wanted to. 60s, 60 seconds equals 1 min. I'm not going to check to make sure you wrote these in, but it might be wise. Large amounts of time we measure in
Hours.
Yeah. You could argue it'll be like days if you're talking, lowercase h, by the way. If you're talking like how long does it take a planet to orbit the sun or something. But, and 60 minutes, our planet to orbit the sun, it's 1 year. But other planets, they'll measure in, some could be days, but some are years. So.
It's still a year. It's just a year for that.
But it might be a Martian year. I'm talking on Earth. So. All right, mass. Small amounts of mass we do in, think metric. Think science class. Grams. Here's the difference. I don't know if you guys have studied that or not. Weight is a measure of the force of gravity on something. Okay, you just learned it. Okay, mass is how many particles, well, not number, how much stuff is in it. It's independent of gravity. So on the moon, I weigh less, but I have the same mass. So, okay, we'll just leave it for that. Okay, medium amounts of mass instead of a gram, we use a kilogram. In parentheses, I'm going to put a kg. How many grams in a kilogram?
1,000.
How many meters in a kilometer? So, same thing here. 1,000, oops, got stuck on the meters. 1,000 G equals 1 kg. And we're just going to leave off the large. Typically, they just stick with kilograms for that. And then volume. I'm going to throw 2 in here for volume, kind of the metric and then the English. So in metric, we'd say milliliter, milliliter, yep. So lowercase m, lowercase l, or sorry, lowercase m, capital L. Then medium, we have a liter. You can think of how big is like a 2-liter bottle, or a lot of your water bottles are about a liter. And if you're going from milliliters to liters, it would be same as millimeters to meters, which would be 1,000. So 1,000, lowercase m, capital L, equals 1 capital L. And we will leave off the other as well. Then volume for English stuff. Here's where you'll see on like 2-liter bottles and stuff like that, you're going to see like FL, I wouldn't write this, but FLOZ. So you could look at ounces as being a weight or a volume. This is fluid ounces. We're just going to kind of ignore fluid ounces and just kind of pretend those don't exist. Instead, we're going to go right to like a smaller 16 fluid ounces is 1. Does anybody know that?
It's 2.
Starts with a P?
Pint.
Pint. Yep. So we're going to say the small measurements is going to be a pint, or lowercase p, lowercase t. And next biggest thing we're going to say is a quart, which abbreviation would be lowercase q, lowercase t. And does anybody know how many pints in a quart?
4.
Nice try. It's 2 pints equals 1 quart. 4 quarts in a gallon, which is maybe what you're thinking of. Should we put in the gallon for volume, or should we just leave off the big volume?
We could do gallon.
It's up to you. If you want to include it, go for it. So gallon. So G-A-L-O-N. Ooh. Maybe a G-A-L. I don't have this written down. Probably G-A-L, because lowercase g would be grams. Capital G would be like giga. How many quarts in a gallon?
4.
Nice. 4 QT equals 1 GAL. Quarts, Q. Okay. Sorry, I digress. All right. So what would you use to measure? Time to tie your shoe. Hopefully you'd measure that in seconds. You could just do a lowercase s if you want to. Time to build a boat. Probably hours. You know, you could maybe argue like days or something like that. Days, years. Hours is good. So if you were to, on like the quiz or test, time to build a boat, if you were to put down days, yeah, I'd smile and nod, give you full credit. Years, I'd probably shake my head. I wish you'd done this, but I'd probably let you get away with it. So, I mean, there's some flex in there. Fair enough. You don't need to read my mind. All right. Time to run a mile. Minutes. Weight of a car. Probably pounds.
Isn't it like 3 tons or something?
Like trucks are going to be up in the tons. I guess honestly, I don't know how much my car weighs. They actually will. If you look at, if you open up the driver's side door of your car, there's a sticker that'll tell you the mass of your car in kilograms. You could maybe argue tons, but that's probably more going to be like a semi-truck or a pickup truck or an SUV or something. Weight of a ring?
Carrots.
Ounces. Ooh, carats. Carats is going to be the weight of the diamond, or maybe it's for all gems. But a carat is a way of measuring weight for like diamonds. Mass of a ring. Grams. I like that. And once you buy like a wedding ring, like they have like the mass of my ring, then they look up how much is it per gram of platinum, then they tell you how much my ring is worth. Volume of a water bottle? Yeah, probably liters.
Oh, that's tight.
So liters. If you wanted to say milliliters for that, I could be convinced of that. That'd be fine. Volume of a dose of medicine, that for sure would be milliliters. You okay on that page? And very last thing, then we're done with this. Length. Metric for length, you're probably going to go with, I'm just going to write a bunch of them in. So I'm going to say millimeters, comma, so millimeters, mm, could be a cm, could be a m, I don't know, maybe km, then I should probably stop. But that's pretty much all of them. So millimeters, centimeters, meters, you're going to do something like that. So if I were to look at this here, that's on my screen, that's about 1 centimeter by 1 centimeter. Do you agree if I wanted to get the area of that, I would do 1 centimeter times 1 centimeter? And for units, that would give me centimeters squared, because centimeters times centimeters. So area is going to be a unit squared. So mm squared, maybe cm squared. I'm going to do comma, dot, dot, dot. Could be meters squared, could be kilometers squared. But areas are always going to have that squared because area is always looking at, like, what's this times that. It's going to be like, how many square centimeters could you fit in there? Volume, then, is going to be that. Should have made something I could easily, I guess that looks pretty good. Do you agree I'd have another centimeter there?
Yeah.
So now when I do volume, length times width times height, I'm going to get centimeters cubed. So maybe I'll start with the millimeters again. Doesn't matter if you do it a little differently. The key is it's going to be some unit cubed, even meters cubed, comma, dot, dot, dot. Good? By the way, a cubic centimeter is equal to 1
Milliliter.
Nice, 1 milliliter. 1 milliliter is something that's a centimeter by centimeter by centimeter. Okay, US, because we're sweet, we do it all messed up. In length, we talk about inches or feet. Should I just do dot, dot, dot? Yards, miles, something like that. For area, we're going to do inches squared, maybe feet squared. If you count up the number of tiles in our classroom, it'll give you the number of square feet because each tile is 1 foot by 1 foot. If we're talking about volume, now we just same thing, but it'd be to the third power. Agreed? So inches cubed, feet cubed, comma, dot, dot, dot. Officially, but technically for these, do you agree usually they use things like gallons or quarts or ounces or something like that. But okay. If you wanted to measure the area of the classroom floor, I kind of gave it away. You'd probably go with, yeah, you could go with like square feet or maybe square meters. Volume of a gas tank. What would you do for volume of a gas tank that's not on the chart? Gallons. Or if you're in Europe, instead of gallons, they'll say
I'm in Europe.
liters. I suppose for that, if you would say like cubic inches or cubic feet or something like that, I'd have to give you credit. How wide is your table that you're sitting at? Probably measure that in
Don't rage at me when I use
inches or
okay? Don't rage.
centimeters. Maybe meters, 1.4 meters or something. Oh, you could do feet, sure. Could do feet. Yeah, it looks like it's about 4.5 feet, something like that. That's it.